Today, in this video, we are interested in looking at summary statistics, or what we call descriptive statistics. And we want to use a data set, the high-risk data set, to do a few things. So that's the data set. We have renamed it as DF, the high-risk data set. If you want to know where to get it, if you come to the console in Art Studio, and you put in and then you see a list of the data sets that are installed when you're installing the AL base. So that's the one we want to look at. So the head will give you the first 6 observations, and we can see there in the console also. Then the data type, the structure of the data, it tells you that the sepal length, the sepal winged, the petal length, the pental winged is numerical, while the species is factor. It has 3 levels, and then that is the data type, and then the structure. It tells you that we are dealing with a data frame. If you wanted to view the data, I can type view with capital V. If I say DF, and that is the IRIS data set that we are talking about. It has 150 entries, it has 5 columns, and there are 3 species. Each species has 50 values or entries: Setosa vescala and Virginica. So, having said that, we want to do some summary statistics. What we mean is we are getting the mean value, the median, the standard deviation, the minimum, the maximum values, and we have 2 packages that we want to use. So I want to remove the species column. So if I was to view DF2 that I've renamed, you realize that I've removed the last column using the select function that is part of the tidyverse package. I can do start sum, which is start.descriptive or df2, and if I type down here start.sum, it gives me the various summary statistics for the 4. There are 150 entries and so on. Some might not make sense to you. So what you do normally is you could end up picking a few that will add up to what you want to do. So I want to introduce another library, which is the neatal, because I want now to organize this. And so what I want to do is I want to select specific values, 1, 2, 3. I want to pick the minimum value, number 4, maximum, and the age, up to 6. Then I pick the median, I'll pick the mean, and so forth. Then I pick the confidence interval for the mean, and I pick the standard deviation, and these are the numbers that are picked here. So if I was to run that, this is what will appear as my table. I'll pick the minimum value, maximum value, the age, the median, the standard deviation, and the confidence intervals for the 4 columns of the data. I have given it a caption, the title of the table, the height is dataset summary statistics. Remember, I picked this from the parts that have previously been populated here or been computed there. I'm using the format simple. There are different formats for the kable function. There is a pipe, there is a simple, HTML, LaTeX, and RST. I'll not go through all of them. Allow me to do that. And then I want the values to be in 2 digits. If I remove this, it will give me so many decimal points. And then the column names, I can define them as sep.length, sep.winged. That way you could rename them to what you want so that they'll appear there in the table. I'm able to output my values neatly in a table with the different values that we saw. I picked them from the analysis that I have done previously. So that's what I could have done to have some summary statistics from whatever I'm doing. Other ways of getting summary statistics, I want to use the same data. This time I want to summarize. I want to group by the species. So if I come and type DF3, and what happens, we can see It tells me I have three species. There's a sepal length, the mean value, sepal length, the median, and the sepal length, the standard deviation, sepal length, the mean value, and the list. So you can output them in a table format. And that's what I've said. I said group by species, summarize across everything, list, you have the mean, the median, the standard deviation, the mean value, and the maximum value. So if it's the sample length, it will give me mean, median, standard deviation, this is median, standard deviation, mean, and maximum. The sample width, the same case, the petal length, and the petal width. And if I want to view, this is what will happen. I have a lengthy table with all the different values as I was mentioning them. So this is where now I'm more interested to see which species has longer. So for example, here if I look at the sample length, the Virginica species has the longest sepal length. And is it the same case with the sepal wing? Yes, we have one here, and we can see the biggest, the one with the highest, longest sepal winged is the first one, the Setosa species that we have, and so on. So from this, you can do your discussions if you're doing some analysis and so forth and so on. So that's what we have. And then you can also look at the summary of the original data set, which is the iris data set, and this is the summary statistics. If I just use the command summary, that is what I'll get. Frequencies and percentages, I want to use a Duplex package because in the Duplex package there is a data set called the Star Wars, and I call it Star. I want to view the data. That is how the data looks like. I'll not go into a lot of details also about the data. You can install the Duplex package, and then you get in this data set here. That will help you to do whatever you need to. If you're not too sure what the dataset is all about, you can go to Google and check through. Now, what I want is I want to select three columns: sex, height, and mass. Sex, height, and mass. These three columns. So that's exactly what I'll do here. And then I group by sex. Why am I grouping by sex? Because sex is a categorical variable, or it is factors, none, male and female. And I say to remove any NAs that is not a number in the data set should be removed. You can see them appearing here and there. NAs, NA dot omit removes them. Then I wanted to summarize the data in frequency. It gives me how many are male, how many are female, and so forth, and so on. So if I was to view this, what we are calling star one, I see female, they are 9, male they are 44, hermaphrodites are 1 and none are 4, and the percentages are given by utilizing the mutate percent. Is it takes the frequency that they created in line 55, it divides by the sum, and then it multiplies by 100 to give me the percentage. So I'm able to get a percentage. I could do the same by just saying table factor, it tells me the group in each category, just like we had before. But this time you note that they seem to be, some value seems to be more. The reason being is that we had not removed the NAs. What about if I want to compare two columns, sex and gender? In this case, I can do table as factor, sex, and then so it tells me female who are feminine, they are 16, hermaphrodites who are masculine is 1, and male who are masculine is 60. Those who are none in the two categories, they are feminine is 1 and the masculine is 5. So we can use a data set to just get some summary, descriptive statistics, percentages, and also frequencies. You can get tables. You can also visualize. We are not going to do that today. Another library is the Palmer penguins. We could view the data, penguins, and that is the penguins data set that we have. We can easily get it, and these are the different types of penguins, there's a species, their island, the length of the bill, the wings, the depth, sorry, of the bill, and also we have the mass, the sex, and the year. And that's the data we have. So if I do this, let's see what happens. It allows me to look at the data in terms of this output here, X tabs species. There are three species and they are from three different islands. Some species are not found, some are found in all the islands, others are found only in a specific island. Or I could have done table, it will still give me the same results. So X tabs and table gives me the same results. What about plot table? It gives me this. I multiply by 100 so that it gives me the percentage. So underline species. Yeah, these are the numbers. This percentage is out of 100 for all together. That's why this is 12, 16, 15, 19, 36. If you sum that, you get 100. Or I could have just gone looked at this, the penguin species in each of the three species and the number that we have. And so the majority are then derived, then found by the Ginto, and then the chin slab is the last type of species. So these are examples of summary statistics that I wanted to share with you today. And thank you so much for watching my videos.